In today's world, while handling quality or quality improvement efforts, we come across several numerical data like our inspection record, inspection values, customer complaints under different categories, and so on. Statistics is inevitable for quality because, as I mentioned, we need to handle several numeric data, and the method to handle the numeric data and arrive at the decision is statistics only. Many people have a feel that statistics is something uncomfortable to learn. I'll remove that myth as I move forward in several sessions. And statistics, since it is inevitable, if we start learning from basics, the statistics will be very easy to implement and take decisions for quality improvement. Hi, this is Jagdish Kumar R, Master Black Belt 6 Sigma, Certified Reliability Engineer, Certified Manager for Quality and Organizational Excellence from American Society of Quality, Lead Auditor ISO 9001-2015, taking this session. Let us set an objective for today's session. This is a session only to appreciate statistics. The topic of statistics as such I will cover in the future sessions. Appreciate why statistics in quality improvement. This is very important. Once you understand why statistics in quality improvement, you will learn statistics, make it interesting, implement and take quality decisions. Know what is statistics for quality in simple words, and I'll give a simple 5-step approach to data-based quality solution, that is statistical approach to quality solution. Let us remember now onwards, the best decisions are the best informed ones. Any major decision you would like to take, whether it is quality improvement or our career decisions, we go for data and we need to take the decision based on the data. For example, if an individual wants to shift from company A to company B, he or she will not do it without any analysis. First, we will study the new company, its performance, how it handles employees, how the work environment is going to be, and then only we take a decision to switch over to company B. Means we are doing data analysis and then taking the decision even in our lives also. Now, why statistics for quality analysis? 1. Poor quality can be a disaster. This we discussed. A company that does not produce quality cannot survive. Quality problems are everywhere. That means every company has quality problem, and every company needs people who know statistics, apply statistics to know the actual difficulty from the data and take actions, permanent actions, so that the quality problem does not repeat at all. Another advantage of statistical analysis is early detection, because early detection is a must in quality improvement. We cannot create defects and then do the corrective actions. If we plot a simple control chart, that will tell if there is a slow deterioration in the process, maybe a tool wear out and so on. And before we suffer rejections, we will be able to identify the trouble and take remedial action. You can appreciate how this is helpful, that it will save a lot of revenue for the company in terms of eliminating the wastage due to defect. Quality improvement decisions cannot be based on hunch or perfection. If you take such a decision based on hunch or perception, it will never be sustained solution. As I told, only numeric data, that is called alternatively as statistical data based on quality measurement, the measured values like inspection records, monitoring of quality, maybe before improvement, afterwards, post improvement, and decisions for improvements can only give a permanent benefit. Means numeric data can only help you to come to a permanent decision on quality improvement. Now some examples of quality data like field failure data, this is a statistical data, inspection data, customer satisfaction data, supplier quality data. These are the examples of statistical data. Please remember now onwards, statistics is the backbone of quality. Without statistics, you cannot be a quality practitioner or any practitioner nowadays. As I told, even HR needs statistics. Now let us have a brief understanding of definition of statistics for us to present during the interviews or to be able to explain in simple terms to our subordinates or team members in the company. Statistics for quality is a numerical data based approach. Numerical database can be my set of readings for 100 boards. What are the lengths of the boards? For 100 boards I have collected. Now this becomes a simple statistical data and we use it for quality improvement. Now some simple guidelines, I will not call these as steps, but these are the standard guidelines given in the international materials for quality improvement through statistical data. I'll condense this and using my experience give you a 5-step solution later. Ensure measurement system is reliable. This is very important. What I measured, if it is not from a reliable vernier, say for example for the length of the board, if the vernier has an error, then what is the measurement I take and note down and then take the decision? Definitely is going to be erroneous. So first you have to see that your measurement system is good. Then you have a plan to collect the data. Many times if you do not plan, there is a proverb, failing to plan is planning to fail. If you do not plan how you want to collect the data, what data only you want to collect, you end up collecting lot of data which are not necessary and waste enormous time also. Time is money in business, isn't it? So have a collection plan, data collection plan, and then actually collect the data. You can assign this to one member of the team if you are working in a team and do the job. But important, collect what data is required only. Now, having collected the required data, do the data analysis and process analysis. Data analysis can be in the form of a quick, I would say histogram. It can be in the form of a Pareto chart to know the vital fews. It can be a control chart and so on. Now, why I brought under point number 4, process analysis, because you analyze the defective products, understand the reason for defects, but most of the times you would see the reason for defect will be in the process. So you need to improve the process, which is the cause for bad product. When you improve the process, the permanent gain will be there. That's why process analysis obviously happens after you do the defect analysis. Identify the root cause. There may be several causes which we can compile using the cause and effect diagram. You identify the primary reason, the basic reason for the failure from the cause and effect diagram from your experience, and that is called as a root cause or a valid cause in this case. For that cause, you can work on, or you can pick up 2 or 3 possible causes which you feel can be the reason. Then you can sit with your team and decide on the best solution, or you can present it to management and take management's approval also to implement one of the best solutions. After you do the improvement, you need to make the parts, or you have to deliver the service if you are in a service industry, and see that what is going to be the performance. In case of products, we can do the inspection and measure the new improved values. In case of service, you can take the feedback from the customers or the users on how their experience is, user experience is with the new service, with the improved process. document changes for permanent benefit, because if it is memory based, it will become person based. After the person is transferred or if the person leaves the company, then that wealth of knowledge gets lost. That's why things have to be systematized by converting the knowledge into the document and making it document based. Some common statistical tools for your understanding. These are from 7 basic quality tools, which I will explain in an interesting way later. Check sheet, stratification, histogram, scatter diagram, Pareto chart, control chart. All these are examples of statistical tools. AQL, that is acceptance quality limit, or some people say acceptable quality limit. It is like this: if somebody says AQL is 98%, say the customer says, that means if you take 100 numbers, maximum 2 can be defective in the lot. 98 minimum should be good, say boards or resistors. Okay, in such a case, AQL comes into play. This is also a statistical data. This I will explain during my sampling session. And CPK, that is process capability index, is also a statistical data. I will explain this when I handle the process capability session. Now I told you I'll give you 5-step solution for statistical analysis in quality. Let us come to step number 1. These are all from the wisdom of my experience over 35 years. First, develop a clear problem statement. You know the proverb, a problem well defined is problem half solved. Many people make a mistake here. If you define the problem clearly, your future direction towards solving the problem will be perfect and you will be able to reach to the perfect solution. Please remember this. Develop a clear problem statement should be the work that where you need to put good amount of effort or spend a good amount of time. Step 2, do data-based analysis as below. Once you know your problem, you go to inspection department, collect the inspection data. You go to marketing, collect the customer feedback data on that particular problem. Now you have a set of data. For that, you should first form a team. As I mentioned, together everyone achieves more. If you have a team, the collective wisdom will lead to very enhanced analysis and solution. This has been my experience. Many standard companies have approaches like suggestion schemes where 2 or 3 employees come together and solve the problem, or quality control circles, or Six Sigma. All of them I will explain in the future sessions. The team now should sit together. They should plan what data to collect. They should assign responsibility to 1 or 2 members of the team to collect the data. Now what should be done? Collect failure data for quality problems, maybe from inspection department, or if it is customer related, from market department. If it is supplier related, again from supplier development group, and so on. Analyze the failure duty using statistical tools, simple statistical tools which I told, like stratification, Pareto chart, control chart, and so on, will help you to arrive at a statistical solution, which you can convert into practical solution as I explain later. Now let us be able to define what is statistics, because many times people attend interviews, they may have to explain what is statistics in simple words. If you know it in simple words, definitely you will be able to explain in simple words also. And for those people who may have to teach their subordinates or team members in the company, this will be very useful. Interpret data to find the root cause of failure. This is very important. You should be able to very clearly interpret the data. People will have a lot of data. People may do a lot of charts and figures, but they may not be good enough to pinpoint the root cause. It requires some kind of an experience, and experience can be gained only by trying it out. As we say that a journey of 1,000 miles starts with a single step. You start solving small problems, and finally, I know you will be confident. Success breeds success, and you will be able to solve higher level problems. Okay. Do not worry, you will be able to identify the basic reason, root cause from the data and arrive at the best root cause. There could be 2 or 3 root causes you might suspect. Arrive at the best root cause, implement and demonstrate. If it doesn't improve, look at the second reason and the third reason, and so on. What I am trying to say is there could be more than one root cause for a given problem. Please note this. Many people make a mistake that there is going to be only one root cause if for a given failure. It is not true. Present the data to management or team to select the best solution for the root cause that you have identified or get management's approval. Next, after yes from the management, apply the best solution to eliminate the root cause. Means whatever solution you have decided, now apply it on the process, that is manufacturing that defective item. Most of the times the improvement will be in the process or on the product. And now what we need to do, it is not enough if I declare that I have implemented the improvement. Step number 4 is very important. Collect the quality data after improvement. With the improved process, improved say material, make n number of parts, maybe small quantity of 50 numbers or 5 numbers. Ideally, make them, check whether there is an improvement that is visible. If that is so, then you can demonstrate this to management for management's approval. Now once the management's approval happens, it is very important. The most important step in my view is step number 5, that is document the improvement. How do you do? You have to modify standard operating procedure, SOP, including the new process. Or product drawing may need a correction. Suppose you have gone for a material change, alternate material, alternate component, and so on. Drawing may require a correction. Bill of materials, in simple words, past list, may also undergo a revision. Some big companies have their own company corporate standards. If there is one improvement you have done and it can be implemented in 200 or 300 products across the company, the best practice will be take this improved process into the company standard and publish it across the company, so that the benefit is leveraged into all the areas where this improvement can create value and benefit for the company. Now, implementing statistics, I will share my experience. I have worked in quality domain for 35 years. Step 1, problem statement. I have taken a case here. The problem statement goes like this. Rejection of electrical coils due to high resistance. Visualize. Resistance is high, the electrical coil is getting rejected. So the first question obviously that comes to your mind is, what is the specification? So specification is 25 ohms plus or minus 0.1 ohm. What is the meaning? The item can be 24.9 ohm on the lower side. Less than that is a rejection. Maximum it can be 25.1 ohm. Beyond that is a rejection. To solve this, a small team was formed. This was a very critical part for a medical device, so it was very important for us to solve this at the earliest. So as I mentioned, the best practice is form a team. If it is cross-functional team, it is still better. The team collected the inspection data as per the data collection plan for 100 coils. What was the outcome for the 100 coils? 88 coils were accepted, but all the 88 coils had the values which were above 25 ohms, which is the target, and no T1 one number was less than 25.1 ohm. So what is the problem? There is a drift. This is the benefit of statistics. Before rejection itself we are able to visualize. There is a drift that the coil resistances are on the higher side alone. But unfortunately 12 got rejected. This was our another major concern. So we took this problem based on the data. We presented the data to the team because together everyone achieves more. I told there will be collective ownership if you involve the entire team while taking major decisions. The team analyzed the problem and came out with cause and effect diagram where 3 causes were found as the probable valid causes. One was the wire diameter, the second was the mandrel diameter. Mandrel is the support on which say 200 turns of the coil gets wound. If that dimension is getting different from the specification, then the coil resistance will change. I'll show the mandrel in my next slide. Or it can be that the tension we have provided for the wire to do the winding, because loose wire will become a haphazard bunch. The tension we would have given to the wire is not correct. Only 3 reasons could be found as valid reasons. How this was solved using the statistical data? Just see here. Team decided to check the winding mandrel also because wire was correct and it was within the specification. Second option, that was to check the winding mandrel. All the dimensions were cross-checked and they were found perfect. Now how a mandrel looks, for your information, it is a cylindrical portion that gets wound on the winding machine. The yellow portion where the stem is, the 200 turns of wire gets wound with under tension, and that tension is exerted by the tension meter. Now you found out that out of the 3 reasons, 2 reasons got eliminated through statistical analysis. The team verified the tension used for the winding and the tension meter was showing the perfect reading, 1 Newton. 1 Newton was to be applied, tension meter was showing 1 Newton only. But now from our analysis we know there cannot be any other reason than tension meter being the culprit. So what was the option? Obviously the team decided to go for recalibration and if required repair of the tension meter to ensure correct tension on a wire while winding. We did that and there was the culprit, the hidden culprit. Error was in the indication of a tension by tension meter. Tension meter had a deficiency. It was indicating 1 Newton, but actually it was exerting 1.1 Newton. The repair was done, recalibration was done, it was mounted back on the machine and 1 coil was wound. It was giving a perfect reading. Now the problem got solved permanently only through statistical data in a simple way. I think this should give you confidence that applying statistics is not complex, and statistical data only can help you not only to come out with the permanent quality improvement solution, also to understand and recognize if there is a small deterioration happening so that quickly you can solve that problem and avoid defects and wastes. Step 4, after improvement we cannot straight away declare, we need to demonstrate the improvement. What we did, we wound 50 coils with the repaired, improved tension meter, recalibrated tension meter. The result was all the 50 coils got accepted. They were very close to the target and spreading on both sides, upper side as lower side. That means the process got centered and the result was 100% pass. We modified the SOP because 5th step is to document so that the improvement is system dependent, not person dependent. SOP was modified with the instruction. I'll read it for you. Verify correct coil tension before starting the new lot. Means you verify that machine is showing, the tension meter is showing 1 Newton. But it may be applying some other tension. So to cross check, what we did was, or what instruction we are giving to the operator is, use a standard tension meter along with the machine tension meter. Use another high quality standard tension meter in tandem, so that both should read 1 Newton. That means the tension meter on the winding machine is also showing perfect reading, to confirm correct tension on the winding wire before the production. So this was introduced. If we make a lot of 1000 numbers, 2000 numbers, only in the beginning we do this cross checking with the standard tension meter along with the machine tension meter, confirm, and then we go ahead with the winding, because these are all high-end medical electronics coils where we cannot take any risk. So as I was explaining, numerical inspection data and quality tools only could solve this hidden quality problem. This was a hidden problem. So what is the one more benefit of statistics? Not only defect elimination, not only drift identification, hidden problems also can be solved, which otherwise gets unrevealed, and the problem becomes continuous. Now to sum up, statistics for quality is using numerical data like inspection data or customer feedback data, customer complaint data, and so on, to analyze and solve the quality problem. What is the benefit? Permanent solution can be arrived at. Deeper solution can be arrived at. Statistical quality approach significantly enhances profits, because before you suffer defect, drift, hidden problem, you are solving, and that avoids huge revenue loss to the company. Now to simplify the statistical approach, you start with a practical problem. Practical problem, you collect data. Now what you have done by collecting the inspection data, say you have converted practical problem into a quality problem. This quality problem in statistics get converted into statistical problem, which is utilized to analyze and come out with the statistical solution. Please remember, the tools like Parrot or whatever will give you a statistical solution. You should be competent enough to identify and convert that into the next, that is practical solution. It is not difficult. Based on your practice experience, you will be able to do. Start with small problems, apply, you will gain confidence, then you can apply it for higher problems. As I told, a journey of 1000 miles starts with a single step. Statistics is compulsory in quality for permanent improvement. Now onwards, let us remember that there is no quality profession without the knowledge of statistics. As I conclude, I request you to please subscribe to this channel. This will motivate us to come out with more and more value adding topics, right from fundamentals. Please press the bell icon so that you get the notifications as and when we release our further sessions. Please press the like button if you had liked this simple fundamental explanation of need for statistics in quality. Thank you so much for your support and watching this presentation.